All right, I'm going to show you guys the 2012 number 4 Euler's method. It's probably one of my favorite problems because we learn all these different ways to approximate values. We learn how to write a tangent line, and then Euler's method, which is, the tangent line on steroids. And then we eventually learned Taylor series, which is just incredible. The more terms you do, the accuracy for that. So those are just some of the different techniques we've learned. So there's 4 parts to it. So there's 4 different techniques on how to approximate. It's kind of cool that we're going to be doing the same thing, getting the same result kind of close by doing different techniques. So I think this is pretty cool. So this one's a unique way they do it. They give us a chart of values about the derivative. This is derivative if you pay attention closely. So you got 1, 1.1, 1.2. They are equally spaced. Now they do tell us about the point of the original. F of 1 is 15. Okay, so that's like a C finder. If you had an equation, find the original, but we're going to use it for something else. And they told us the second derivative at 1 is 20. Okay, so we'll find out in a bit what those are for. All right, first off, write an equation of the tangent line at 1 and use it to approximate 1.4. So this whole problem is about approximating 1.4 in different ways. So write an equation of a tangent line. Well, I got the point 115. So I know the point 115 works, but they said write a tangent line at 1. Well, you got to find the slope. Well, the slope at 1 is 8, because remember they told us the derivative. So now we got our tangent line. It says use it to approximate 1.4. Okay, so plug in 1.4. 1.4 minus 1, we got 0.4 times 8, we got 3.2. So add the 15 over, we get 18.2. All right, so that's our first approximation using tangent lines. Okay, so we know the actual f of 1.4 is somewhere near 18.2. All right, part B. They want me to find the integral of that for some reason. We'll find out in a minute. But they want me to use a midpoint Riemann sum. Okay, so we want to find the integral from 1 to 1.4 of the derivative. All right, or t sub an x. So the integral of this from 1 to 1.4. All right, well, if you remember midpoint formula, it's b minus a over n, and we are 1, 2, 3, 4 spaces. All right, and they told us, actually they asked us with 2 subintervals, my fault. Forgot we're doing midpoint, you have to cut it in half. So we're just going to go like this, break into 2 parts. All right, so if you remember, that's your widths, and then your heights are the middle numbers. The middle numbers are 10 and 13. All right, so 10 plus 13, we got our 23. Half of that is 11.5. And then we're going to multiply that by 0.4. So 11.5 times 4, that's 46. So, but it's 0.4, so 4.6. That is what we get for that. Okay, so that's that area. What am I going to do with it? Well, they said use that value to estimate 1.4. You're like, how do I do that? Well, if you remember using the integrals and accumulators, so for example, I want to find f of 1.4. But what do I know? Oh, I know f of 1 is 15. So if I take f of 1 plus, remember like in PVA, we want to, like the integral of velocity is a change of position. So the integral of f prime, if f prime is like our velocity, is a change in f. So if we take an integral from 1 to 1.4 of f of x, that would be the change from 1 to 1.4. Well, we just did the integral was 4.6. So I have 15 plus 4.6, so I get 19.6. So doing it this technique, I get a slightly different approximation, then I got 18.2. Okay? All right, that's 2 down. Third one, use Euler's method. All right? I'm going to need that. So let's fit that in here. Euler's method. Now, do you guys remember Euler's method? I'll write it out one time here. our new y equals old y plus the step, the dx times dy dx. If you guys remember why that works, you have your old y. When you multiply the step, the change in x times dy dx, the dx is canceled, so what you have is your old y plus change in y is your new y. It's kind of similar to what we just did here. So let's see what we got. So we want to find 1.4, but how many steps are we doing? 2 steps. So we already know f of 1 is 15. So I got to get to 1.4, so I have to stop at 1.2. All right, so you take your old y plus the step change. We're going up by 0.2. And then the derivative at this point. So we got to actually plug in the previous point. You remember we plug in where we're at currently to where we're going at. So we're at the point 115. So at 1, the slope was 8. So I have 15 plus 1.6, I have 16.6. But we're going to continue. 1.4, we're going to go 2 steps, get to 1.4. So we're currently at 16.6 right now. That's where we just ended up. So now we got to plug in, like before we plugged in this guy, now we got to plug in our new point. So at 1.2, the slope, the change in x is actually 12. The slope is 12. So the step is still 0.2, then 12. Now the step's 0.2 because we went up another 0.2. All right, so 2 times that is 2.4. So add those together, and we get 19 even. All right, so I'm gonna check. Yep, that's what I got, 19. So now if you see, I've done it a few different ways. I got 18.2, 19.6, and 19.0. So that's your Euler's practice that we did this on. Let's go to part D. Just remember this answer would be 19.6 and 18.2 for that guy. Write the second degree Taylor about 1. Well, to write a Taylor series, I got to know f of 1, f prime 1, and f double prime of 1, and I have all those. So to write a Taylor series, so a Taylor polynomial, it's degree 2, so you can call it a P2 or T2 for Taylor, but we always just put P for polynomial. All right, it's centered. Don't forget it's centered at 1 because these are all at 1. So f of 1 is 15, right? So 15 is our first term of our Taylor series, plus, and then remember our multiplier of derivative is 8, and it's x minus 1 to the 1 over 1 factorial. Remember Taylor series, x minus your center, and then 20 x minus 1 squared over 2 factorial. And there's your second degree. Let's clean it up a little bit. So I'm going to be plugging into it. So I just cleaned that up a little bit, and they want me to use it to approximate, shockingly, 1.4. So I plug in 8 times 1.4. So I got 0.4 times 8, 3.2, so I got 15 plus 3.2, and then I got 0.4 squared, so 0.16 times 10, so 1.6. So final answer, I get 19.8, I believe. Let's see what that was. Yep, 19.8. So all our different approximations for different ways. So you can see we did an calculus AB method in A, just writing a tangent line, and then we AB also does the part B where you have to use one known value to find another known value, and then the new stuff for your BC being Euler's and Taylor's. All right. So I really like this problem just because it's all the different techniques that we've learned over time to approximate values. Okay? All right.